Welcome to another episode of Numbers Microscope. And today we're going to talk about baryons, of which the proton and the neutron are two of them. But they have different spectrums according to the flavor of quarks that inhabit the baryon states. Now, via the 6 flavors of quarks, there are 56 forms of baryon, or groupings of 3. Our proton is traditionally 2 ups and 1 down. Our neutron is 2 downs and 1 up. And the down type of quarks are 1/3 charged quarks, or minus 1/3 charged quarks, whereas the up quark types are positive 2/3. So that when you have a baryon of whole unit charge aggregately, for example, the proton, you have 2 2/3 charged quarks, the ups, and 1 minus 1/3. So 4/3 minus 1/3 gives you 3/3, and then you have whole unit charge, as in 1. There are 56 different types of baryons given the 6 flavors, of which 36 of them will be 0 charge and +1 charge, as in the proton and the neutron. 20 of them will be +2 and -1. Therefore, you have 36 plus 20 gives you the full 56. Only the up and the down quarks exist here on Earth. They are the lightest, and it is known now that strange quarks live within stars, which are a much more fierce, high-temperature type of environment. And the strange quark is the most dominant flavor for hadronization, for baryonization, for the formation of the nucleus at different levels of flavor. Strangeness is the organizing principle, and its inherent number within this system is the number 3 for SU3. Now, of course, the relationship between U1 in terms of electromagnetism and the relationship that it has within SU3, the strong force, entails this relationship between 1 and 3, which just happens to be very nicely addressed by the number 13. Because these numbers are active within this type of syntactical mapping of 1 into 3. Because at the center of a cube octahedron, which is made up of 13 spheres, 12 around 1, the central sphere opens into a triangular face 8 times over, because there are 8 triangles that the cube octahedron consists of. And in the symmetry breaking of the 1 and the 3 that destroys or displaces the number 13 in its integrity. It just so happens that because 13 is a period 6 prime, if you want to know what mathematical tension exists between the 1 and the 3 within the number 13, you have to look at the periodicity of 1/13, 0.76923. Now, what that means is that when you separate the 1 from the 3 and the number 13 and say, where did the 13 go? You're going to have to raise the parts, the 1 and the 3, to the 6th power and take the difference. And so 3 to the 6th power is 729 minus 1, or 1 to the 6th, is 728. Which gives you 13 times 56. And so what you see is that this number 56 is inherent in the way in which the 1 and the 3 are regenerated, once that symmetry between U1 and SU3 is broken, it requires this element of 56ness, which are the baryons, in order to restore that broken symmetry. It just happens to be there. Hold that thought.